Hi, and welcome to my Ubisoft Next Showcase submission for the 2018 showcase. My name is Martin Briand, and I'm a computer science student in this third year at the University of Toronto. This year's challenge theme was pinball. So the main focus that was immediately apparent would be to create the realistic 2D vector physics to represent real life physics because we want the ball to be able to bounce up and down. This was one of the biggest challenge out of this coding competition because we had to get the physics right so it's realistic and looks like regular flipper or just flipper games that you see on computers. So there was a lot of research that was put in that to be able to see how to recreate regular physics in C++. The first part that was essential was to handle collisions. So this was done with impulse resolution. So you can just get the vector while you collide with an object of where your ball is supposed to bounce back. And this was challenging in a way because we were using 2D vectors, so just lines, instead of actual rectangles for the surfaces. So this made it we had to detect edges to know how we need to bounce and to know which way is up or down of that vector. Then the ball not only bounces, but also needs to roll when it's going at a different speed. So we had to implement rolling physics into this. So we can just do that by setting the velocity down the slope. So when the ball is in contact with a vector, we can just calculate that and make it go to this direction. So this is essential for the ball to bounce and roll to. The flipper part, so what hits the ball, has a different behavior. So unfortunately, it doesn't behave like the rest in the way that it's actual physics calculations that go in place. It's different so as to have a better gameplay feel, because after a lot of testing, I found that using a different way of collision, just detecting when the ball is going to be a hit and which direction it's going to be from that, was better than applying physics frame by frame to the ball when it was being hit by the flipper. And so for the collision, there is also a sort of padding. So when you enter an object, but after the frame after your velocity makes it so you'd be inside that object, this is avoided by calculating the radius of the ball and the distance to the object to solve the penetration problem from the ball to planes. So in the game, I decided to go to keep the editor line settings that we had. So there were different line types from the editor. So this way it was easier to implement how to bounce against a certain wall. So a wall that would be straight could just be a certain type of wall. So in that case, it was wall soft. So the bounce wouldn't be as hard. It would be a softer bounce. And then the one that are more vertical or line type hard. So this saves a lot of time because that differentiates it easily. Also, this makes it, because all the calculations are done with lines, which is the tag given to the editor, really easily editable levels. And so I was able to make many levels, and I made one that worked really well. That's good, but it's really easy to edit and change everything, but the code still works. There's nothing to change. Because the flipper too are a C-line segment that's being updated according to a flipper object that takes the input, but the line itself is a C-line that's in the file. Then the collectibles are part of that too, because to save memory, they're just a line type score, I believe. And so to be able to know when they're collected, when you collide with them, once they're collected, it gives you a Boolean. And so how I did that to save some memory was to set a value from the unused data, because the editor used more data to the line types. I just set it to be able, the M selected, it decided whether or not it was collected or not, and then I can do calculations with it without using extra memory. So if I had more time to work on this project, because the time constraint was definitely a big part of the challenge, being able to have multiple balls would be a good part, because it would add a lot more maybe adding more type of scoring and other more gameplay elements to it. Uh, so in the code structure, so we have the game tests that were given to us, and to make things like a lot cleaner and like clearer to understand, I decided to create a pinball machine class that hosts the three different flippers, so the two bottom one and the top one, the ball, and that handles all the game states, so game over and restarting and initiating everything. This is also the class that like loads the level from the editor. So this way it was like much clearer. So we don't have much classes, but they like communicate between each other real good. Another thing that I decided to make was create my own Vector2 class because I used it so much throughout the project. And the one that I created just like has just what we need. So like having the X, Y, and being able to do dot products, normals, and like normalizing vectors, because that's how the calculation goes on in the background. Uh, then in terms of gameplay, so like the main thing that changes from regular pinball is the addition of the super meter. So it's like a cool little thing that just like gives an incentive to like get the points. So like after 10 points, you get to use a super hit thing that gives you a cool trail behind your ball, and it's just like gets you even more points, and that's like making the game a little more fun. Then apart from that, we just have like the regular flippers, like an extra one in the top left, so it'll add a little more dynamic, and like you can like have interactions between the top part of the screen and the bottom. And yeah, that's about it for my game. Hope you appreciate the gameplay in the background. And thank you.